we're moving on to the vertex form and the intercept form. Hopefully we went over this during class today. If not, jot these things down and we'll make sure we go over it during class tomorrow. We should have gone over it during class today at the end as a transition into vertex form. Hopefully we notice the similarities between the absolute value function and vertex form especially. As we look here, instead of having an absolute value function, we have a quantity squared. Everything else that we knew about an absolute value function will work the same here. We still open up if a is greater than 0 and open down if a is less than 0. We're still wider if a is between -1 and 1, or narrower if a is less than -1, greater than +1. Extending from standard form, we do know the vertex is h, k. The same idea applies on the inside. Minus will tell us to move right, plus will tell us to move left. On the outside, the plus will tell us to move up, the minus will tell us to move down. These are the same as the absolute value function. That still is the case. Inside is the opposite of what you think. Minus right, plus left. The axis of symmetry is x equals h. Still, remember the axis of symmetry goes through the x-coordinate of our vertex. So that is h. That's why the axis of symmetry is x equals h. So as we move on to this graph here, let's first describe it. This opens down because a is less than 0. This is wider because a is between -1 and +1. Our vertex is the ordered pair, -3, 4. Again, this tells me to shift to the left 3. This tells me to go up 4. That's my vertex. And my axis of symmetry is the line x equals -3. So let's go ahead and start by plotting our vertex, -3, +4. That's our vertex. Let me give us our axis of symmetry. It's right there. We can see that. You don't always have to draw that. It just helps us right now to understand it a little bit. So we start with that information. And from here, we just have to pick a couple of points and see what we get. I'm going to personally start here with -2. So if we make our table of values, when x is -2, I get +1, +1 squared, times -1/2 is -1/2. This will give me 3.5. So I go to -2 and 3.5 right there. If I go to -1, the inside will give me +2. +2 squared is 4. -1/2 times 4 is -2. This is going to give me +2. So -1, +2. And I'll do one more in this particular one. I'll use 0. I get 0 squared, or 0 plus 3 is 9. I'm getting ahead of myself here. 0 plus 3 is obviously 3. 3 squared is 9. 9 times -1/2 is -4.5. Plus 4 is -0.5. So that will give me 0 and -0.5 right there. So again, we could go to the left of the axis of symmetry, or we could just use that axis of symmetry and plot our points here in the same way we have this. And we're good to go now. Hopefully we can see that is a little bit wider than our parent function. Again, the negative is what tells us that that opens down. The intercept form, we are given the intercepts. In this case, we are getting the x-intercept. Our vertex form is y equals a times the quantity x minus p times the quantity x minus q. This, again, opens up if A is positive, opens down if A is negative. Wider and narrower are the same as the last two that we've seen. The new information here, the x-intercepts are p and q. Again, opposite. If minus p, let's say for example, we'll see in the next one here, the x-intercepts are p and q. The axis of symmetry is halfway between p and q. That's something we'll need to use here in our next example. So as we look here, this opens down. A is less than 0. This is going to be the same width because A equals -1. That's the old information. Okay, now our x-intercept. Again, inside is the opposite. We have x equals -2, and we have x equals +4. So we can go ahead and plot those points. -2, +4. We are going to have those points on our graph. We know that. Now, our axis of symmetry and our vertex are halfway between those. So let's just go with the axis of symmetry. X is going to be equal to, let's add these two together, and then divide by 2. -2 plus 4 is 2. We have 2 over 2, which is 1. So our axis of symmetry is the line x equals 1. Now, in this particular case, it probably would have been just as easy to count in from the intercepts. We could have done that. I just wanted to show us that we can just add those two together and divide by 2 to quickly get that as well. Now, we know that the vertex is on this axis of symmetry when x equals 1. So we need to substitute 1 into our original function up there and see what we get. So 1 plus 2 is 3 times -3. So we end up with -3 times -3. This is actually going to give us +9. So when x is 1, y is 9. Technically, we can be done with our graph now because we have a point on both sides. We know that it's U-shaped. So as we come on up, it's going to look just like that in intercept form. That's all we have for today. We'll continue practicing these tomorrow during class, in addition to the other ones we have already learned. See you tomorrow.